Welcome to the chapter 6.3a lesson video, solving inverse equations with change in the period. Now, this first lesson video isn't going to be about solving so much as identifying how many possible solutions there's going to be when we do solve. So we're breaking this into two parts. We're doing both parts this week. This first video is just about determining the number of solutions, because if you know the number of solutions, then when you actually get to solving them, it'll be a lot easier to make sure you've actually found the correct number of solutions. Okay, so let's go ahead and dive on in. All right, so today we're going to talk about how we can determine the number of solutions to trig equations, even with modified periods. And then the next video we'll talk about how to solve those equations and actually get all those possible solutions. All right, so let's talk about determining the number of solutions. So there's really four key scenarios that really come up that we have to keep in mind as we're doing these problems. And these are kind of like the base number of solutions that a lot of things have. You got to be really careful of some of them. But it's really helpful to keep these in mind. So when solving equations, it's important to be able to find the number of solutions. Without doing so, it's often easy to just miss one or miss a couple of them by accident. Most trig values have two solutions. So, for example, the cosine of x equals 1/2. That'll happen in two instances, right? It would happen in quadrants 1 and 4. That's the two places where cosine is positive, and that's a 60-degree reference angle. So that'd be 60 and 300 degrees. So that's two solutions here for that one expression. So that one x value could be two different things to make that statement true. Lots of things have two solutions. Basically, anything of a 30, 60, 45-degree reference angle that we're familiar with will have two solutions almost all the time. All right, now the next one over here is some quadrantal angles only have one solution. Okay, so these are things like sine of x equals 1. That only happens at one place. That only happens at 90 degrees. These are good things to memorize. So a couple of them are things like sine of x equals 1, or -1. So let's actually call that plus or minus 1. That'll be a little less to write. Sine of x equals plus or minus 1. Cosine of x equals plus or minus 1. Secant of x equals plus or minus 1. And cosecant of x equals plus or minus 1. These are the ones that only have one solution. Cosecant only equals 1 at one spot. And so keeping that in mind is really helpful. Now, something that a lot of people kind of confuse here is they see later on, they'll see tangent of x equals 1, but tangent of x equals 1 is actually over here in the two solutions. They get that one part confused because tangent of x equals 1, that happens at 45 and 225. So that one actually has two. So be really careful there. That's something to kind of try and keep straight in your head. The next thing is that square roots double the number of solutions. So the reason square roots double the number of solutions is what you would do is you would take the square root of both sides. So this is going to become the tangent of x equals plus or minus the square root of 1. And so when you take that square root of both sides, you have to do that plus or minus piece right here, and that'll double the solutions. So tangent equals 1 had two solutions. Tangent equals 1 had two solutions. We just kind of talked about that, 45 and 225. But tangent equals -1 also has two solutions, 135 and 315. So because we square rooted it and it made that plus or minus, it now doubled it because now we have to account for both the positive and negative sections. So we end up with 1, 2, 3, 4 solutions rather than just tangent of x, which equals 1, having two solutions. And then one last thing to keep in mind is that sometimes there's no solutions, right? So sine of x can never be 5/2. So this is a no solution situation. The best way I think to remember it is remembering this little image here, 1 and -1, that sine and cosine need to be between 1 and -1, whereas secant and cosecant need to be above or below -1 and above 1 or below -1. All right, so something to keep in mind, that those are kind of some limitations that we have to keep in mind. So sine of x being 5 over 2, that's not possible, because 5 over 2, that's 2.5, which is bigger than 1. Same thing with like secant. Secant cannot be 1/2, because that's between 1 and -1, where secant cannot exist. All right, let's go ahead, let's keep going. Let's do some practice of these problems. Okay, so there's one last thing we need to talk about when it comes to number of solutions. So those 4 things we talked about on the previous slide were kind of the basics of normal solutions. But one other thing we can do is we can alter the period, which causes solutions to happen more frequently. And what it actually does is it multiplies the number of solutions that there would normally be by whatever the period modifier is. So this number in here is the period modifier. So this number on the inside next to the x, if you see a number on the inside next to the x, what it does is it multiplies the number of solutions that there would be normally by that number. And this is that new thing that we're going to talk about in the next video on how to actually find those numbers of solutions. Right now we're just talking about figuring out how many there are. We'll actually figure out how to find what they are in another video, in the next video. So what you kind of do for these is you just draw the picture, you say how many solutions there are, and then you multiply it by that number. So cosine of x, 2x being root 2 over 2, well, cosine of x happens in 2 places. It's a positive, so it's going to happen in 1 and 4. I don't really care what those angles are right at this moment. That'll be for a later time. So that's 2 times 2 more. So for this problem, there would be 4 solutions, because there's 2, and then the period modifier is times 2, so it doubles the number of solutions. Over here, we have tangent of 4x equals -1. So that would be 2 solutions where tangent is -1 in quadrants 2 and 4. Be careful on that one. That's when some people get mixed up. So that's 2 solutions times the period modifier of 4. So 2 times 4, this would be 8 solutions. All right, that's 8 solutions. All right, and then this last one, sine of 3x equals 1. Well, sine only equals 1 in one spot. That's a good thing to remember. Sine only equals 1 in one spot times the period modifier of 3. So this one would be 3 solutions. Okay. Now, one thing to keep in mind, and this is just a little side note, no matter what, if you have, let's say something like this, a trig function equal to something that it can't equal, right? Sine cannot be equal to 3. It doesn't get that big. It has to be between 1 and -1. It doesn't matter what the period modifier is here. Undefined is still undefined. There are still going to be no solutions in that situation. And if you have something where there was a squared, so say we had a little bit something different. We had tangent squared x equals 1. So, sorry, let me change that a little bit. Tangent squared of, let's say, 3x equals 1. Say we have tangent squared of 3x equals 1. This one, we will have 2 solutions for tangent equal to +1 when we square root both sides, and 2 solutions for tangent equal to -1 from when we square root both sides. And then both of those are times 3. So that's 4 times 3. This one would have 12 solutions. So no matter what it is, no matter what scenario is set up it is, if there's a number on the inside, you multiply it by how many solutions there would have been, and that tells you how many solutions there's going to be. Now, we don't know what those solutions are, but we'll cover that in our next video. All right, so with that, you should be able to get started on this first assignment. If you want to watch the next video right away and figure out how to find those solutions, it's not a bad idea. If you want to take a break, work on the assignment, and then come back to the next video, that's also great. All right, I'll see you in our next live session, and until then, I hope you have a great day.